Alright, today's lesson 6-7, we're going to be solving radical equations and inequalities. It's all a one-day lesson because solving equations transfers over to the inequalities. Alright, first of all, when you've got a radical equation, you want to get your radical on one side by itself. So isolate the radical on one side. Then, step 2, you're going to raise each side of the equation to a power equal to the index of the radical to eliminate the radicals, and then you're going to solve the resulting polynomial equation. Be sure to check your results because you could end up with extraneous solutions, meaning false solutions. Let's take a look at my first example today. I have the square root of y minus 2 and minus 1 equals 5. We're going to isolate the radical, so I'm going to add 1 to both sides. That's going to give us the square root of y minus 2. Adding 1 to this side results in 6. Now I want to raise both sides to the second power to eliminate the radical. And what I end up with is just y minus 2 equals 36. I'm going to go ahead and add 2 to both sides. Y equals 38. It's important now that you go ahead and check your solution. We're going to plug 38 into this thing. So we're looking at the square root of 38 minus 2, then minus 1 equals 5. Let's see if this is a true statement. 38 minus 2 is 36. So I'm looking at the square root of 36. Minus 1 equals 5. The square root of 36 is 6. 6 minus 1 equals 5. That's true. And so this is the answer right here. Okay, I'll show you one that doesn't have the correct answer or has an extraneous solution. This example. Alright, step 1, we've got radicals on both sides. So what we're going to do with this is we're going to square both sides of my equation. That's going to eliminate one of the two radicals. So square the front and square the back. The front, fairly easy, you get rid of the radical sign. The back, remember, this is going to be 2 minus root x times 2 minus root x because it's squared. Now we're going to FOIL this out. 2 times 2 is 4. I've got a minus 2 root x and another minus 2 root x, so that's minus 4 root x. And then negative root x times negative root x is a positive x. That's equal to x minus 12. Now I'm going to get this radical over here all by itself on this side. I'm going to subtract 4, so negative 12 minus 4 is negative 16. I'm going to subtract x. X minus x is gone. Alright, so I've got negative 16 equals negative 4 root x. Now I need to divide both sides by the negative 4. Negative 16 divided by negative 4 is a positive 4 equals the square root of x. And now I'll square both sides to remove this radical. Results in a statement of 16 equals x. But importantly, you need to plug that 16 in up here. So I'm looking at the square root of 16 minus 12 equals 2 minus the square root of 16. Now 16 minus 12 is 4, so the square root of 4 equals 2 minus the square root of 16. That's going to be 2, and that's 2 minus 4. 2 equals negative 2. Not true. So this is not a solution. There is no solution to this problem. Alright, let's take a look at something other than just a square root. This is a third root. So remember, I need to isolate the radical, or the thing that's being taken to the third root. I need to isolate that on one side all by itself before I do anything else. So I'm going to subtract 5 from both sides. That will result in 3y plus 1 to the 1/3 power. Next, I'm going to take both sides to the third power to eliminate this 1/3 power. Take this to the third power, take this to the third power. This will result in just the 3y plus 1, and this results in negative 125. Now solve this equation. Alright, I'm going to need to subtract 1 from both sides, so that's going to be negative 126. This will be 3y. Now I divide both sides by 3, y equals negative 42. Now check your answer. Always check your answer. Okay, so when I plug a negative 42 in this becomes 3 times negative 42 plus 1, whole thing to the 1/3 power plus 5. We'll see if that equals 0. 3 times negative 42 is negative 126. Negative 126 plus 1 is negative 125. I'm taking that to the 1/3 power and adding 5 and seeing if I get 0. The third root of negative 125 is negative 5, and I have 0. This checks out. This is a solution. Okay, that's it for equations. Let's take a look at inequalities. Now, one important part of the inequalities. If the index of the root is even, we need to identify the values of the variable for which the radicand is non-negative. In other words, we're going to make sure that whatever's inside the radical of an even index radical is not negative, so we don't want to go imaginary in this thing. Then we'll solve it just like we did before. Okay, so on this one, we have two parts to this. Part 1. This thing right here has an index of 2. So what I need to do is I need to make sure that this 3x minus 6 remains non-negative. So I'll just set it up like this. Non-negative means that it can be greater than or equal to 0. Solve this little problem. Add 6 to both sides. Divide by 3. Okay, so whatever x is, it's going to have to be greater than or equal to 2 to keep this thing from being negative. All right, now step 2. We're now going to go ahead and solve this just like we did with the previous equations. The square root of 3x minus 6 plus 4 is less than or equal to 7. I'm going to subtract 4 from both sides. So 7 minus 4 is 3. So I have the square root of 3x minus 6 is less than or equal to 3. Now to get rid of the radical, I square both sides. And that will result in 3x minus 6 is less than or equal to 9. Let's add 6 to both sides. 9 plus 6 is 15. So 3x is less than or equal to 15. Now divide by 3. Remember, if you multiply or divide by a negative number, you've got to remember to flip that sign over. This is a positive number, so I won't flip. 3x divided by 3 is x. 15 divided by 3 is 5. But these two will make up your answer. All right? Your final answer in set builder notation is x, such that here we see that x has to be greater than or equal to 2, so I say 2 then has to be less than or equal to x, which also has to be less than or equal to 5. What this answer means is that all of our solutions have to be between, including 2 and 5. All right, so from 2 to 5 are where all of our solutions are. If I go less than 2, that makes this imaginary, can't be done. If I go greater than 5, this becomes false. All right, so that's today's lesson. Thank you for watching. We'll see you next time.